compliance with the standards may not necessarily be compliance with the legislation. If you have a look at 4777.1, in a lot of instances, they say use the manufacturer data or guidance out of AS/NZS 3000.
Yep.
So this is why I keep going back to RTFM. Whereas the neutral to inverters is just one element of it.
Right.
There's so much other stuff in there. And it all has to tie together correctly.
The question is, do inverters really need a neutral? In this short video, we answer that question, and it's taken from a longer podcast. Now, don't forget to like, comment, and subscribe to this channel. Now, let's get stuck into it. Let's talk about inverters.
Yes.
And also the fact that, actually, invariably going back to cable, in some situations, you don't have to run a neutral from the inverter. Now, is it a case that, hey, if there's a attachment, a connection within the inverter, a compliant inverter, and there's a neutral attachment, you use a neutral? If there's none, you don't? Or is there other rules and regulations? I know this is a bit of an interest, it's a complicated area, Gil.
It is.
And I'm sure it'll be brought up in the training at some stage,
Yep. Well, not only that, I'm hoping I can give a good answer.
Please.
There will be obviously different thoughts on this out in the industry, and that's all good. Okay, so take it as being just a black box that we're connecting up to a supply.
Yep.
And look at it from terms of what are we actually going to do with this? And I'm sort of thinking about it in terms of it's a solar inverter, it's a motor, it might be a heater bank, it could be a whole heap of different things that in some cases, for what you're doing with it, you may not necessarily need a neutral. So, for example, three-phase motors, they don't need a neutral. Heater banks, for example, they don't need a neutral, depending on how you're running them. So similar sort of theory is that you are assuming that your connection between your three phases to a central neutral point is maintained at a switchboard or somewhere where you've got, obviously supply coming in from your transformer, trying to keep things balanced, because as soon as you start throwing things out of balance with your three phases, you actually shift that neutral, either towards one phase or away from two, or it depends on the configuration and network impedances and current flows and all this other stuff. So, when you're looking at that, having that neutral at the inverter might just be something to do internally with the inverter itself, or it could actually be, something to do with how the inverter needs to generate its supply and push the power back out onto the grid.
At the end of the day, there has to be an MEN link, there has to be an earth, there has to be a neutral somewhere.
Yes.
And I know with on HV sites, there's the neutral within the transformer. Is that right?
Yeah, so where you step it down to low voltage, yes, you've got your three phases, your neutral, and some form of neutral earthing for most installations. If you have some other thing that you might need to do, like it might be a mine site or something, like a higher voltage supply, you might not necessarily have that neutral reticulation. You might have a resistor, you might have a reactor, you might have some sort of impedance earthing scheme.
Right.
And it gets into a whole different realm
of
earthing. Yeah. And so where you're looking at a standard supply to a site, you've got your three phases and your neutral being reticulated around. For a TNS system, you are earthing it at one point and one point only. For a TNCS, which is what our standard AS3000 distribution scheme and your houses on the street type scenario, that's a TNCS is an MEN. It's a true MEN, multiple earth neutral system, where you are earthing the neutral at different points, even though you are reticulating that around your supply. So that has different functions. So, for anyone to say, okay, there's a rule of thumb for neutral and neutral earthing and earthing, no, it's not the case. It changes depending on your application.
I'll give you an example. 400 volt nominal, 9 sun grows, interface protection, transformer stepping up to 22 kV straight to an RMU, ring main unit.
Yep.
No neutral required on those particular inverters. Now, you've got the quizzical look, but
RTFM?
well, yes, absolutely. Read the data manual.
Yes.
It's so there's what I'm trying to say. It's up to, I suppose, the distributor has a massive role to play in whether they accept it or not. But isn't it the overriding scenario that if the inverter itself has a neutral connection and it's compliant, you're going to use a neutral. If it doesn't and it's compliant, there's nowhere to connect the neutrals into the inverter. Is that what it comes down to at the end of the day?
At the end of the day. So if we look at certain things, if we look at our structure of how we have our connections, obviously we have our legislation, we have our standards, and in our standards we have AS NZS 3000. Where we have AS NZS 3000, underneath that, and bearing in mind that 3000 is an umbrella standard.
Yes.
And a whole heap of different standards fall out underneath that.
Yep.
And so you've got 4777.1, which is all about how you connect in inverters into an electrical distribution system. So if you have a look at 4777.1, in a lot of instances, they say use the manufacturer data or guidance out of AS NZS 3000.
Yep.
So this is why I keep going back to RTFM, because that's generally the first place I'll actually look.
Yeah, gotcha.
As to how you structure this properly. So where you have these types of connections and scenarios and everything, inverters are just electrical equipment that you are connecting to a distribution supply. The overriding principles of safety, compliance, will it do the job for an electrical installation is what you need to adhere to. So neutral or no neutral, that's just one element of safety or compliance that you have to take into consideration, whereas all the other stuff that's there has to obviously go by the standards. So it's interesting. It sort of, where we talk about that, and I'll quickly sort of go across to this very, very, very quickly, is that there's a point where you say compliance with the standards may not necessarily be compliance with the legislation.
Right.
So there's things in here from an overarching perspective that we need to do properly for assessment, whereas the neutral to inverters is just one element of it.
Right.
There's so much other stuff in there.
Boy.
And it all has to tie together correctly.
So really, at the end of the day, and I'm always trying to find some kind of statement that covers, and in most cases it does work. You're talking about, I don't know. I actually don't. I'm flummoxed at the moment. Yeah.
Okay, so
yeah.
Where we talk about, for example, a neutral connection into an inverter, there might be other elements that we need to take into consideration. That might be there for protection. Protection is the overriding side of things. So if that neutral is supplied to an inverter, if the inverter manufacturer says we want a neutral there because if there's an internal fault,
yes,
then we just want everything there to try and keep it our phases balanced, or have low impedance path for, like, if it's a neutral,
even if the fault is 200 milliseconds or something, it's still...
It's amazing what can happen in 200 milliseconds under fault conditions.
Yeah, right.
Yeah, there's a lot of things, and depending on whether or not that it's high voltage, low voltage, could be some lightning protection, that sort of stuff. There is so much different variability with all regards to this. Where you have your supply being reticulated through, it's very important that that is connected correctly and that all the fault protection side of things is all taken in consideration. Where that inverter has a neutral may be listed there by the manufacturers for protection and functional requirements. And if you look at requirements for electrical equipment, protection is the thing that we are trying to achieve primarily. If there's secondary or tertiary functional or other requirements, then we have to go with the highest, I suppose, the highest priority one.
Is this what, like, as part of a protection study, is this what the PowerCAD takes into consideration? It looks at those things as even that nitty-gritty with...
Well,
Yeah.
it looks at, for example, if we have inverters that are installed a certain distance away from a switchboard, that our protected device is properly rated, protects the cable in the event of a fault at inverter, that it will protect the cable. It will automatically disconnect the supply. So trying to remove the faulty part of an electrical installation while keeping the rest of it online.
Yeah.
And making sure that time, as you said before, that 200 milliseconds, safety-wise, we have the rule of thumb in ASNs at S3000 that an earth fault go no more than 0.4 of a second. Ideally, we're trying to cut that as quick as possible because it could be that you're standing there doing something on that inverter or close by where that fault causes the earth to rise in potential, and then you become part of the earthing system.
Yeah, right.
This is where we have issues with it, with EPR, touch voltages, all this other stuff too, where you are, trying to protect personnel first, and then equipment and installation after that type thing.